Practice page for section 6.4. It's on isosceles triangles. For each triangle, find the values of the variables. So what's going to happen is they're going to give you an isosceles triangle like this one. We know it's isosceles because these two sides are congruent. We have an isosceles triangle theorem that tells us if these are the legs, then this is the base. So that makes these two angles the base angles. If there's two congruent sides in a triangle, there's two congruent angles. This is where they live. These two angles, even though they're marked differently as x and y, they're the same. This angle up here is 116 degrees. Now remember, we have a triangle exterior angle theorem. So if you know that angle, these two right here add together to give you that one. And if they're both the same, then 116 divided by 2 gives you 58. That's the measure of each angle. Both of these angles are 58 degrees. Now, you're not always going to be able to use the triangle exterior angle theorem here, but it worked out here, and it's a quicker way to do it. Number 2, you have a right isosceles triangle. Well, if you remember back to classifying triangles, there's only one type of right isosceles triangle in the world, and that's the 45-45-90. That's your vertex angle because it's in between the congruent sides. These are your base angles. They're the same. So if you already used 90 degrees, you got 90 degrees left to use. 90 divided by 2 is that 45. That's where these two 45s come from. Now notice how this one leg has a length of 6. How long is this other leg? It's going to be 6 as well. Your legs are the same length. Number 3, we have two isosceles triangles. Well, maybe we don't. We have one isosceles triangle. That's this guy right here. So this angle that has one arc on it and this angle that has two arcs on it most of the time are different. But if these legs are the same, then these two angles are the same as well. So what's going to happen is all of these angles are the same. They're all y degrees, because if this angle matches this angle, then they all match each other. So same thing, you have an exterior angle, that's going to be the same as these two added together. So this might look weird, but 63 divided by 2 is going to give you your answer. That'll be 31.5. And that'll be the measure of all of those angles. So that's what y gives you, 31.5. So if you got two 31.5s, remember that gives you that same 63. That's 63 degrees already. If you do 180 minus 63, that gives you the measure of that vertex angle. So that's the value of x. Number 4, you have an isosceles triangle. That makes these the base angles. So if this angle is 40, doesn't this one have to be 40 as well? 4 times a number plus 20 gives you 40. Write that equation. Subtract 20 from both sides, and then divide by 4. Number 5, it's an isosceles triangle. These are your base angles. If this angle is 40, this angle is 40. If you have two 40-degree angles, you have 140 degrees left to use. No. If you have two 40-degree angles, that's 80 degrees. You have 100 degrees left to use. So this vertex angle is 100 degrees. So 4 times a number plus 10 gives you 100. So 4 times a number gives you 90. 90 divided by 4 gives you 22.5. Again, that looks weird, but that's your answer. Here's an isosceles triangle. Notice how these two sides are the same, and these two sides are the same. So if this side's 18, This side's 18. This side's 18. That's how long that side is. Now you also have to find this base angle over here. It's not going to be the same as these base angles necessarily. That's your vertex angle, 54 degrees. So what's left over from 54 degrees? 126 degrees. You need to split that. So they're both 63 degrees. Now, this 63 degrees is an exterior angle for these two remote interior angles. Well, what's 63 divided by 2? I already did this one. That'd be 31.5. Number 7. In this triangle, ABC, angle A and angle C are equal measures. So that one's 38, that one's 38. That makes the big triangle isosceles. Find the measure of angle A. Well, it's 38 degrees. Find the distance from A to D. Find the distance from A to C. Well, if this is an isosceles triangle, then those two segments are the same, remember. So 4 times the number minus 2 is the same thing as 3 times the number plus 4. We'll subtract 3x from both sides, and then we'll add 2 to both sides. This is not what they ask you for. They ask you for the lengths of those sides. So plug that back in. X is 6. 4 times 6 is 24. 24 minus 2 is 22. That's how long that piece is. Well, how long is this piece? Well, 3 times 6 is 18. 18 plus 4 is the same 22. You shouldn't be surprised that they're the same. Remember, they needed to be the same. Okay, last one. In triangle JKL, segment JK is congruent to segment KL. That makes an isosceles triangle. So you know these two angles are the same. So they're telling you the measure of angle J. It's 4x minus 8. They're also telling you the measure of angle L. It's 3x plus 15. If they're the same, set them equal. We'll subtract 3x from both sides. Then we'll add 8 to both sides. X is 23. But they didn't ask you to do that. They asked you to find the measures of the angles. So I'm going to use my calculator here after I drop it. Take the value of x and plug it in. We're going to do 4 times 23 minus 8. And that gives you 84. Now we also have to do 3 times 23 plus 15. So both those angles are 84 degrees, and that's really what they ask you to find.